Hello everyone. In today's video, I will be covering a topic degree of kinematic indeterminacy in case of truss. Okay. So, and this video is the continuation of my last video which I have uploaded, and in my last uploaded video I have covered the topic how to find the degree of kinematic indeterminacy in case of beams considering it was the neglecting the axial deformation. Okay, so now let's start with the topic degree of kinematic indeterminacy in case of truss. So we have a formula for finding the degree of kinematic indeterminacy for truss, that is dk is equal to 2j minus r. So this is the formula for finding the degree of kinematic indeterminacy, and I have already mentioned that the degree of kinematic indeterminacy is denoted by the term dk. Okay, d suffix k, and the other name of the degree of kinematic indeterminacy is degree of freedom, and in short we can write DOF. So now I'll start with the topic. So degree of kinematic indeterminacy in case of the truss. So this is the formula. So here j indicates the number of joints and r indicates the number of unknown reactions. Okay, so now I'll take one example of a truss, example number 1. Okay, so this is a truss. Okay, here one end is a hinge support and the other end is roller support. So here the figure is like this, okay, for a truss. So now we have a formula with us, dk is equal to 2j minus r. Here how many joints are there in this figure? See, 1 2 3 4 5 and 6. So in this case we have number of joints is equal to 6 and number of unknown reaction, that is r. So here r is equal to, see, in this case one end is hinge and the other end is roller. So for the hinge support, as I already told you in my previous videos also, so in case of the hinge we have two unknown reaction, that is one is along the vertical direction, we can assume it as y direction, and one is along the horizontal direction, let it be along the x direction. So now in case of the roller support, how many unknown reactions are there? There are only one unknown reaction, and the direction of this reaction is vertical, that can be a y. So in this truss, how many unknown reactions are there? That is 1 2 and 3. So we have 3 unknown reactions. Now what we need to do is we need to put these values in this formula, that is dk is equal to 2j minus r. So 2 into j is 6 minus r is 3. So how much we'll get? 6 to j 12 minus 3, that is 9. Okay, so here for this figure the degree of kinematic indeterminacy value is 9. Then now we'll check whether this answer is correct or not. So we have a alternative way of finding the dk value here. So okay, so I'll redraw the truss here again. So see, this is the truss which is given in the question, right? Here vertical, and so this is, so we'll divide this truss and the supports. So see, this truss and this support we have drawn separately, and always remember that in case of the truss, in each joints will have two deformation, that is along the x direction and along the y direction. Okay, in each joints. So here also there will be two unknown reactions, here also there will be two unknown reaction, here also there will be two unknown reaction, here also and here also. Okay, So now here we know that in case of the hinge support we have two unknown reactions, right? That is along the x and the y direction. And in case of roller support there will be only one unknown reaction. Okay, so now what we have to do is, this support is here. Okay, it was here na, and this support is also here. So this force and this force will get cancelled in this case, and this force and this force will get cancelled here. And here for the roller support, this upper force and this upper force will get cancelled. So how many forces is remaining? See, 1 2 3 4 5 6 7 8 and 9. So here dk value is 9. So see, this is a manually calculated value. Okay, calculated value. So by using the formula we got the answer around 9, and by manually also we are getting the same answer. So our this value, that is degree of kinematic indeterminacy for this types of truss, is 9. Okay, so I'll take one more example. Okay, so this is a truss. This is a truss. This truss is like this. Okay, so here one end is hinge and the other end is roller. Okay, so now here also we have to do the same thing. We have a formula with us, that is dk is equal to 2j minus r. So this is the formula for finding the degree of kinematic indeterminacy in case of the truss. Now how many joints are here? Let's count. 1 2 3 4 5 and 6. We have j is equal to 6. And how many reactions? Unknown reaction is equal to, in case of the roller there will be only one unknown reaction, and in case of the hinge there will be two unknown reactions. So total number of reaction is 1 2 and 3. So 3. So what we have to do here is dk value, just we need to put all the values in this formula, that is 2 into j is 6 minus 3. So again 6 to get 12 minus 3, we are getting the answer around 9. So here for this case also the degree of kinematic indeterminacy is 9. So now let's check manually also. So in manually we have to draw the diagram separately. So the diagram was like this, right? Like this. And support one is hinge and the other one is roller. So as I already told you in the example number 1, that in each joints we have two unknown reaction, that is vertical and horizontal. Here also it will be like this, here it will be like this, here also, and here also. Now we have two supports, one is this one hinge and the other one is roller. For the roller there will be only one unknown reaction, and here in case of the hinge there will be two unknown reactions. Now see, this vertical and this vertical will get cancelled, in this horizontal and this horizontal will get cancelled, and in this case for the roller support this vertical and this vertical will get cancelled. Now how many unknown reactions are present here? Let's count. 1 2 3 4 5 6 7 8 and 9. So here see, the decay value is equal to 9. So this is also a correct answer. This, by using the formula we are getting decay value is 9, and manually, this is the manually calculated value, that is also 9. So this is also correct. Again I'll show you one more example. Okay, so here see, what example do I need to give is, okay, so example number 3. So this is a truss, and here also one side is hinge and the other side is roller. So the truss figure is like this in this case. So now by using the formula, we know the formula, that is dk is equal to 2j minus r. So here how many joints are there? That is 1, 2, 3, 4, 5 and 6. And how many reactions, unknown reactions? That is 1, 2 and 3. Here 3. So if we put all the values in this formula, that is 2j minus r. 2j minus r is equal to 2 into 6 minus 3 is equal to 12 minus 3 is equal to 9. Okay, here also we are getting the same answer, that is 9. Let's calculate manually here. So we have to separately draw this like this, okay, and the supports, hinge and the roller. So here how many unknown reaction for in each joints? Vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, like this, right? And in case of the hinge also it will be, we know that there is two unknown reaction, that is along y and along the x, and here in the roller support there will be only one. So just check here now, this and this will get cancelled, this and this will get cancelled, this and this will get cancelled. How many remaining will be there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here also decay value is 9. So this is also a correct answer. So this is a calculated, manually calculated value, and this is by using the formula for finding the degree of kinematic indeterminacy. So likewise we have to calculate the degree of kinematic indeterminacy in case of the truss. Okay, truss, in case of the truss. Now in my next video I will be discussing about how to find the degree of kinematic indeterminacy in case of frames considering the axial deformation. Okay, so next will be all about the frames where we'll be considering the axial deformation. Okay, thank you.